Hello everybody, Beaton here and welcome back to another past paper video. In this video, I will be tackling some linear programming question. So let's head straight into this question. So it says, the diagram below shows the graph of three lines and a shaded region, S, defined by three inequalities associated with these lines. The inequality associated with the line y equal 3 is y is greater than or equal to 3. And this is basically telling you what is going on in this diagram here. So the first question says, state two other inequalities which define the shaded region. So the shaded region would be this region here. So they want two other inequalities that will define that shaded region. So you already have y is greater than or equal to 3, which took into consideration this line here. So what we can do, we can take into consideration this line and get the inequality for that. How can we get the inequality for that? By, we see it's x plus y is equal to 10. So let's see. So let's put in a value. Let's put in a value. Let's choose a random point in this shaded region. And let's see, let's choose this point here. So let's choose this point here. So this point here is 3 across and 5 up. So it's 3, 5. So let's see if this is greater than or less than 10. So let's see. So this is 10. So let's see. So x plus 5 would be, we know x is 3 plus 5. And we know this is 10. So 3 plus 5 would be 8. So 8 is obviously less than 10. So we see when we put in a pair of points, the answer will be less than 10. So let's use another coordinate to see if we can if we will have the same result. So let's choose one right on the line, x plus y equal 10. Let's choose one right on that line, which is this point here. So let's see if that will give us direct 10. So we go 4 across and 6 up. So the point here would be 4, 6. So let's see. So x would be 4 plus 6 would be 10. So 4 plus 6 is 10 is equal to 10. So we see it's also equal to, so we can say the inequality that we can use would be x plus y would be less than or equal to 10. Because when we put in values in the shaded region, we have x plus y is less than or equal to 10. All of the values here. And if you go and choose another point here, if you go and choose that point there, we see that is 3, 6. So if you put that here, let's see that it satisfies this inequality. So 3 plus 6 would be less than or equal to 10. So 3 plus 6 is 9. So 9 is obviously less than or equal to 10. So that's satisfied. So that is the other inequality we can use. X plus y is less than or equal to 10. So you can say x plus y is less than or equal to 10. And that is how you can get these other inequalities, by substituting values into the shaded region, and it must satisfy the inequality. So let me erase this here now. So that is one. So let me see if I can find another one. So the other line that I have would be x equal 2. So I see, of course, all the numbers here will be numbers greater than 2. So the next inequality that I can have would be x is, since this is a solid line, the 2 is a solid line, I can say the other inequality will be x is greater than or equal to 2. And let's put in some values and see that will satisfy this. Let's put in a value here. So we see obviously here the x value here would be 3. That is obviously greater than 2. And let's put in another one here. That is 4. That is obviously greater than 2. So x is greater than or equal to 2. So the other inequality would be x is greater than or equal to 2. So next one says the function p is equal to 5x plus 2y minus 3 satisfies its solution set by the closed triangular region. Identify 3 pairs of x and y values for which p has a maximum or a minimum value. So they want 3 pairs of x and y values for which p has a maximum or minimum value. We can go back to the diagram. So those 3 pairs of x and y values would come at the vertex of the triangle, which would be here, here, and here. So all we need to do, so the point here would be, we go 2 across and 8 up. So the first one would be 2, 8, And then the other point, we go 2 across. And this here is our 3 up. So to be 2, 3. And then the last one, we go, this was a 7 across and 3 up. So this would be 7, 3. And those would be the 3 pairs of x and y values for which p has a maximum or minimum. So next part is, which pair of x and y values makes p a maximum? So they want us to justify the answer as well. So what we need to do, they told us that p is equal to 5x plus 2y minus 3. So let me write that. So p is equal to 5x plus 2y minus 3. And they want us to find which pair makes p a maximum. So they want us to find which pair of coordinates will allow p to be the highest value. So what we need to do, we need to substitute all of those coordinates into this here to get which one will be the highest value for p, or which one will result in the highest value for p. So let's use the first coordinate, which is 2, 8. So the first one is 2, 8. So we know p would be equal to 5 multiplied by x, which is 2, plus 2 multiplied by y, which is 8, minus 3. So this will give us p would be 5 times 2 is 10, plus 2 times 8 is 16, minus 3. Hence p would be equal to 10 plus 16. 10 plus 16 will be 26. 26 minus 3 will be 23. So here p has a value of 23. Now let's find the other coordinate, which is 2, 3. So let's go. P is equal to 5 multiplied by x, which is 2 in this case, plus 2 multiplied by y, which is 3, minus 3. So we have p is equal to 5 2 is 10, plus 2 3 is 6, minus 3. Hence p would be equal to 10 plus 6 is 16, 16 minus 3 would be 13. So p here has a value of 13. And the last but not least, we see it's 7, 3. So 7, 3. So this will be p is equal to 5 multiplied by x, in this case, which is 7, plus 2 multiplied by y, which is 3, minus 3. Hence p would be equal to 5 times 7 is 35, plus 2 times 3 is 6, minus 3. So p would be equal to 35 plus 6 would be 41. 41 minus 3 would be 38. So the pair of x and y values that makes p a maximum would be 7, 3. So you can say p is a maximum at 7, 3. And we did this by substituting the coordinates into the p function, and this resulted in p having a value of 38. So the highest value for p will occur at 7, 3. And this is our justification, this is our calculation. And with that, this has brought me to the end of this video of linear functions. I trust that you have a good understanding. I want you to use these concepts to answer similar questions on the linear functions. So join me in the next video in which I'll be tackling another question. So until then, take care and keep practicing.